Hi everyone. Today we're going to talk about how to solve exponential equations. Don't worry, it's not as complicated as it sounds. Before we proceed, kindly like this video, subscribe to the channel and click the notification bell to stay updated with my latest tutorials. In this lesson, we'll go over two main types: equations where the base is unknown and equations where the exponent is unknown. By the end, you'll feel more confident and ready to solve any exponential equation that comes your way. So, grab your calculator and let's get started. All right. Before we start solving exponential equations, let's first understand what makes them special. An exponential equation is a bit unique because the variable can appear either in the exponent, like in 2 to the power of x equals 8, or as the base, like x cubed equals 27. These equations don't behave like linear equations, so we need special strategies to solve them. Now here's the key idea. Solving exponential equations really comes down to understanding how exponents work and how they connect with their inverse. Operations, roots, and logarithms there are actually two main types you'll encounter. The first one is when the base is unknown, like in x cubed equals 27. And the second is when the exponent is unknown, like in 2 to the power of x equals 16. Once you know which type you're dealing with, choosing the right method becomes much easier. Now let's talk about how to solve exponential equations when the base is the unknown. In this case, we use something called root operations to isolate the variable. Remember, roots and exponents are opposites. They undo each other. Here's how it works. Step 1. First, identify the exponent. Look at what power the unknown base is raised to. Step 2. Next, apply the inverse root. For example, if the variable is cubed, take the cube root of both sides. If it's squared, take the square root. Step 3. Then simplify both sides. The exponent and the root cancel each other on the left, and you just simplify the number on the right. Step 4. Finally, verify your answer. Plug your value back into the original equation to make sure it works. That's it. Once you get used to the process, solving for an unknown base becomes quick and easy. Let's look at an example to see how this works in action. We want to solve the equation x cubed equals 27. Here, x is raised to the third power, so to isolate x, we'll need to apply the cube root to both sides. Step 1. Start with the original equation, cubed equals 27. Step 2. Apply the cube root to both sides. That gives us the cube root of x cubed equals the cube root of 27. Step 3. Now simplify. The cube root and the exponent cancel each other out, leaving us with just x on the left. On the right, the cube root of 27 is 3, because 3 times 3 times 3 is 27. Here's the key idea. Taking the cube root of x cubed completely undoes the exponent. They're inverse operations. That's why we're left with x is equal to 3. Simple and satisfying, right? Now let's move on to the second type of exponential equation, when the exponent is the unknown. This time we'll need a slightly different approach. When the variable is in the exponent position, we use logarithms, since logarithms are the inverse of exponentiation. In other words, they help us undo the exponent and bring it down where we can solve for it more easily. There are actually two main strategies we can use. First, the same base method. If both sides of the equation can be written using the same base, just make the bases equal, and then set the exponents equal to each other. For example, 2 to the power of x equals 8 can be rewritten as 2 to the power of x equals 2 cubed. Since the bases are the same, we can set x equal to 3. Second, the logarithm method. If the bases can't easily match, for example, 2 to the power of x equals 10, we apply logarithms to both sides. This allows us to bring down the exponent and solve algebraically. So whenever you see an exponential equation, just remember, If you can make the bases match, do it. If not, logarithms are your best friend. All right, let's apply what we've just learned through an example. Here, we want to solve 2 raised to the power of x equals 16. Step 1. We start with our original equation, 2 to the power of x equals 16. Step 2. Now, we check if both sides can have the same base. We know that 16 can actually be written as 2 raised to the 4th power. So we rewrite the equation as 2 to the x equals 2 to the 4. Step 3. Since the bases are already the same, we can now make the exponents equal to each other. That means x equals 4. Step 4. Finally, let's verify our answer. If we substitute x equals 4, we get 2 to the 4 equals 16. And that's correct. So, remember this key idea. When the bases are equal, the exponents must be equal. That's the magic behind the same base method. It makes solving exponential equations much easier. Now, what if we can't express both sides of an exponential equation with the same base? That's when logarithms, or log in short, come to the rescue. Logarithms allow us to bring down the exponents so we can solve the equation using regular algebra. Let's look at the key rule we'll need, the logarithm power rule. It says that log of a to the x is equal to x times log of a. This means the exponent becomes a coefficient. And that's exactly what makes logarithms so powerful. Let's see this in action. Suppose we have 3 raised to the x equals 50. We start by applying log to both sides. So we get log of 3 to the x equals log of 50. Next, we use the power rule to bring down the exponent. That gives us x times log of 3 equals log of 50. Now, let's isolate x by dividing both sides by log of 3. So x equals log of 50 divided by log of 3. If we compute that, we get approximately 3.56, so even when the same base method doesn't work, logarithms let us solve the equation smoothly and accurately. Now it's your turn to practice. Let's see how well you can apply the methods we've learned. Here are 4 problems where the exponent is the unknown. For each one, decide whether you should use the same base method or logarithms. Let's start with the easy one. We have 5 to the x equals 125. Ask yourself, can I express 125 as a power of 5? If yes, that means you can use the same base method. Next, medium difficulty, still same base. We have 4 to the x equals 64. Think about the powers of 4. 4 raised to 1 is 4. 4 raised to 2 is 16. What's 4 raised to 3? Try to see which power gives you 64. Now for the medium using logarithms. 2 to the x equals 20. Since 20 isn't a power of 2, you can't rewrite it with the same base. So this time you'll need to use logarithms to bring the exponent down. Finally, here's your challenge problem. 7 to the x equals 100. Apply the log on both sides, use the power rule, and solve for x. The key here is to decide which method fits best, the same base method or the logarithm method. Great job, everyone. You've made it all the way through solving exponential equations. That's a big step forward. Let's wrap up with the key takeaways. First, master the fundamentals. Always remember, roots undo exponents when the base is unknown, and logarithms help us unlock the exponent when it contains the variable. Next, choose your strategy. If you can express both sides with the same base, go for the same base method. It's quick and elegant. But if the bases don't match easily, that's when logarithms become your best friend. And of course, always verify. Once you get your answer, plug it back into the original equation to make sure both sides are equal. That's how you know you've nailed it. Now are you ready to level up? Here's your challenge. Solve for x in the equation 7 raised to x cubed equals 10 raised to x. Try it out and share your answer in the comment section below. Thanks for watching. Don't forget to subscribe for more math tutorials.